My name is Jing-Ming Guo, the CTO of Service Systems Technology Center with ITRI. And the topic that I would like to share is about enabling the future of service robots, Taiwan's strategic path to industrial impact. And later I will follow the flow here to provide you a better idea what I'm going to introduce. Firstly, I will define the AI robot, then provide you the vision of the ITRI strategy on this topic, then narrow down to service robot, then development strategy, AI innovations, government resources, and all the way to the ITRI hiring plan, then make a conclusion. And firstly, I would like to invite you to see some interesting video clips in which the robot hardware body is equipped with the cerebellum. So for the first case, you can see the Boston dynamic. You see some alphabets here. And third one, this is here you can see very smooth movements and dancing acrobats. However, there's no interaction with the environment. So for the next case, the cerebellum is equipped with the robot along with the cerebellum. So for the first case, you can see on the top of the corner that was launched by Figure AI, Figure 01 model. You can see the interaction.
Hey, Figure 1, what do you see right now?
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great. Can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great. So based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great. Can you put them there?
Of course.
All right. So how do you think you did?
I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
I agree. Thanks, Figure 1.
You're welcome. If there's anything else you need help with, just let me know.
Okay, here you clearly can see the interaction in between the robot and the human being. And the next case is about the performance of the Figure 02 from Figure AI. It's assembling car parts in W factory. And the next one is Tesla Optimus for the daily tasks. So here you not only can see the smooth action, and you also can see the interaction in between the robot and also the entire environment. So here for the deployment of the cerebellum, we all witness the development on the AI. Since 50s, we start to work with the statistics algorithm to deal with various applications. Then in the 80s, we migrated to machine learning. Then 2010s, we work on the big data along with the deep learning, which is one of the singularity point that the deep learning approach start to come up with the pattern recognition performance that is better than human being. And in 2020, based on the large foundation model, we start to deploy the generative AI. So from the previous demo, you can see the robot along with the deployment of the cerebellum. It can perform the physical and dexterity to learn locomotion, and also based on the simulated motor skill from the reinforcement learning, you can do some acrobats. And after the cerebellum deployment, meaning the visual intelligence and large language model, particular for the multimodal learning and also behavior fusion, then you also can have the audio perception and also behavior interact with the environment. So that achieve the goal of the AI robot with the embodied intelligence, and it can perform daily tasks autonomously. And for the AI robot training, it can be classified into two different approaches. The first is the imitation learning. You can see the robots start to learn the actions from the human being to handle tiny objects and delicate objects. And on the image on the top, you can see one individual is responsible for the training for one robot. So you can imagine, suppose we have 100 people over there. You can train 100 robots, and 100 robots learn different skills. Eventually, we can base on the ensemble learning to putting all the skill in just one robot with 100 different skills. Then based on the duplication, the one robot skill he learns, it can deploy to 1,000 robots. Then based on the reinforcement learning, you can see at the bottom, even during the simulation world, it can still continuously learning. So that is a reason why robot can learn way faster than human beings. On the other hand, for the language model, we all know that it can be roughly classified into 4 stages. For the first one, we try to predict the next word based on the bunch of the data from the website. For example, the Wikipedia, journals, conference papers, or social medias. And for the step 2, all the way to step 4, we base on the handcraft question answer examples and also reinforcement learning, and we can align the preference in between the robot and also human beings. And nowadays, the last stage has been migrated to the reasoning-based reinforcement learning, and we see the permanent improvement as the one case in DeepSeek. So the robot during the training or inference, it can automatically adjust the mistake they made automatically. And for the training data for the robots, in the very beginning, the data from the internet is the most, and simulated data on the second, and the real world robot data will be the fewest. However, as time goes by, if we try to produce more and more robots, then robots can equip with the mobility and interact with the environment. Eventually, the real robot data will getting more and more, and the robot will getting smarter and smarter, and eventually outperform the performance of human beings. So for the forms of the AI robots, we can roughly classify them. The first is the industrial robot. So from time to time, you can see a lot of articulated robots deployed in the factory. So normally they handle heavy duty and fixed space manipulators for the high precision and repetitive tasks. For the service robot, mostly they imitate human single hand or dual hand operations, and the lower body can be equipped with the wheels or tracks. And for the legged robot, it can handle tasks in complex terrain. For the humanoid robot, Normally, they equip with arms and legs. With the general purpose learning deployment, it can interact with human beings or environment. So the reason why AI robot is essential, here I provide some key factors. The first is about the labor shortage. For an ordinary human beings, we can work 8 hours a day. However, for robots, they can work 24 hours a day, 7 days a week, without the risk of the strike currently. And the next reason is that AI robot with the hardware deployed on embedded system inside will be a perfect environment for the AI deployment. The humanoid robot or mobility robots, they can move around the human world to have interaction with the environment to learn and also accumulate the training data. So as time goes by, the intelligence will getting better and better. And another factor is the potential in commercial purpose. For example, there's a tension between China and United States, so the non-China supply chain will drive the export of the critical components. Another comment from NVIDIA CEO Justin Huang, and he mentions that there's a trend toward humanoid robots because the environment of the Earth was created by human beings for a long period of time. For all of the specs, all of the facilities, equipments are adapted for the human beings. So the humanoid robot can easily adapt to this type of environment. And also the human beings collects the data on a daily basis, which creates a rich resources for the robot training, in particular for the humanoid robots. And in ITRI, we have dual track strategies to develop the AI robots. On one hand, we have a bunch of the technology-oriented colleagues working on the core technologies. On the other hand, we have another group of domain people working closely with the industry sectors. And also, we mostly work on the industry-oriented applications as opposed to simply work on the advanced topics only. So here, the value-added AI innovation, for example, the large language model, visual language model, large behavior model, large word model, can be integrated with the robot hardwares, for example, sensor chips, module, power module, battery, four-legged, bipedal, wheel-based robots to create the entire robot development ecosystem. So for the definition to distinguish the service robot from the industrial robot, in terms of the main usage, service robot is more oriented to assist with daily human tasks, for example, cleaning, caregiving. For industrial robot, mostly they perform manufacturing tasks, for example, welding, assembly. In terms of the applications, service robots, they mostly work under the environment of home, retail, and public spaces. And for industrial robots, mostly they work inside factories, product lines, and also work on the automatic facilities. For the design goals, service robots are more interactive with human beings and expected to provide safety and ease of use application. And for industrial robots, mostly they are expected to provide high speed, high precision, and durable functions for the cost and maintenance fee. Service robots are mostly with a lower cost modularized design. And while for industrial robots, mostly they are costly, complex in maintenance. However, that is not always the case, but in general, we can classify this in this case. For the both service and industrial robots, they have shared capabilities. For example, they are expected to have the perception and recognition function to handle the autonomous learning and optimization to improve the skills as time goes by. And also they are expected to have the safety, collaboration, reliability, maintainability functions for the human beings. And here we also conduct a rough survey across different regions and countries around the globe. In terms of the Europe, in 2023, around 34 service robots were sold, which created 6.82 billion revenue as a result. So it has been ranking #1 globally. In United States, 5.78 billion service robot revenue was created in 2023, and it was ranked #2 globally. In China, around 80% of the global service robots are shipped in 2024. In Japan, the total robotics market is around $2.8 billion in 2024. And South Korea service robot market is around $1.04 billion in 2023. So for the applications, you can see quite a few varieties are deployed. For example, for consumer and home service robots, it can do cleaning, lawn mower, and also companions for elderly, and for education, healthcare, communication. For professional service robots, they can handle the material shipping, cleaning, sweeping, and also reception, guest greeting, remote surgery, and also for building demolishing, infrastructure inspection, and also equipment maintenance, firefighting, security patrol. And for agriculture, you can do watering, fertilization, seeding, milking, and also harvesting. So there are quite a few applications over there, and currently we have been witnessing. According to the statistics from the President's research, by 2030, meaning the end of the 2020s, the global service robot market is expected to exceed $150 billion in 2024. Taiwan's domestic service robot industry can generate a total of production value around 14 billion NT dollar. And according to the comments from NVIDIA CEO, Jason Huang, humanoid robot is will be around in a few years, within a few years. It is not 5 years away. Another comments from TSMC CEO, Wei Zejia, he mentions that the multifunctional robots will be a critical direction for the future. For example, the Amazon Astro, it can provide speech assistance, house patrol, image communication, and Kenan T5 can provide meal delivery, guest reception, speech guidance, and also advertisement playback. And for the service robot, Taiwan has two main advantages. The first is about the precision machinery industry. We have more than 40,000 companies in the domain of the machinery and metal industries. And also we are the key component suppliers to Tesla. For example, the Hota Industrial Corporation provides gears and ships. Delta Electronics provides power modules. TSMC provides advanced semiconductor chips. And Petrotron Corporation provides electronics control units. On the other hand, we also provide AI and chip, as I mentioned earlier, for the computing power. Taiwan holds 70% of the global foundry market share, in which 60% is dominated by TSMC, another 10% dominated by UMC. And some global tech giants such as NVIDIA, AMD are spending the investments in Taiwan. And most importantly, you can see the description at the bottom. Taiwan is a trusted global supply chain partner. The evidence I will show you sometime later. So with the integration of the application-driven AI innovations, for example, I mentioned earlier, the large language model, large behavior, large word, multimodal models, and along with the environment we created, for example, industry, academia, research collaboration, startup incubation, supply chain integration, venture capital deployment, eventually, along with the budgets supported by National Science Technology Council and also National Development Council, we have around 20 billion NT dollars in the future to assist on the development of various kinds of applications. And here, Ministry of Economy Affairs initiated 6家 Smart Robotics Innovation and Application R&D Center, in which 2 different platforms are created, including startup acceleration and also co-creation digital twins. For the research energy, we not only can rely on the colleagues inside the center, we also can borrow the energy from the Salon Smart Robotics Research Center, as you can see the one on the top left corner, which was established by National Science and Technology Council. And also we can borrow the resource from the National Development Council that I mentioned earlier, another 10 billion financial support. And also the joint venture from the industry sectors. Eventually, for the mature startups and mature business model, we can introduce them to migrate to the Liuyi Technology Industrial Park to bridge the energy from the supply chains related to the robots. And here you can see the global AI robots industry ecosystem. And here we can roughly classify into 6 different categories, including decision, vision, human-machine communication, power and drive, motion, and also sensors. So you can see quite a few different companies are working toward this goal. On the other hand, you can see the robot industry ecosystem in Taiwan. And also we can classify into 6 different categories. And not only the main categories, you can see some, most of the subcategories, we have multiple companies working on that. So meaning we can build a very strong supply chain and also very resilient supply chain for the entire robot industry in Taiwan. So there are quite a few different applications, as I mentioned earlier, due to the limited manpower and limited resources. Here we would like to focus on the 4 main targets, including the healthcare, logistics, food and beverage service, inspection and disaster relief. So here we can, based on the key hardware implementation, and also the enabling technology we have been working with, including the control, perception, power, software, edge computing, and also intelligent models deployment. Eventually, we can assist the POC sectors and eventually take the global market. So if we have a closer inside exploration on the technology, we can start to see the robot brain from the serviced AI agent. It can be separated into 2 subsystems, including the intelligence and also control. And each of them is responsible for different tasks, for example, the autonomous navigation, behavior interaction, environment perception, event reasoning for control subsystem. You can see the cybersecurity protection, coordinated control, cooperative communication. There's some module shared in between for the intelligence and control subsystems, for example, behavior strategy. And with the incorporation with hardware modules, we can assist the previous ecosystem that I mentioned with the deployment of the application-oriented technology along with the services and system integration with the edge technology and also the virtual digital twin simulation and also the data accumulation. We can assist the 4 topics that I mentioned earlier: healthcare, food and beverage, logistics, and inspection. If we have an even closer look on the technology part, you can see the very complex components over here. And from the bottom, in terms of hardware, we can start to learn local motion system incorporated with sensors and power modules and core components, for example, CPU, GPU, NPU, and communication units. On top of it, we can work on the middleware, not only NVIDIA series of the chips. We can also work on other types of accelerators, for example, chips from Qualcomm, from MTK, from Realtek, and from Apple, and so on. So we not only can work on the NVLink, we also can work on UA-Link, and also we can work on the parallel thread execution to maximize the resource usage as opposed to always rely on the CUDA ecosystem. To the platform, we can interact with the digital twin environment and also robot SDKs to support all kinds of models that I mentioned earlier: language model, visual model, behavior model, word model, to come up with various softwares to handle scene awareness, task reasoning, action planning for the various applications. So for the talents we are looking for, the first type is related to the agentic AI, robotic system engineer, in which this type of engineers are going to explore the multimodal integration and digital twin simulation. The second type of engineers are can work on the embedded system hardwares and middleware infrastructure. For the last one, we are looking for the experts who are experienced and who can provide the strategy and technology comments, advices to lead the strategic planning, ecosystem development, technology direction for the entire intelligent service robot team. So here shows some detailed description. I will leave the PowerPoint for you to have a closer inspection on the details. It can be classified to the agentic AI engineers and also for the strategic and technology experts. So for the conclusion, we all witnessed the stages of the industrial revolution from the almost 300 years ago, dated back in 1760, steam engine invention, then migrate to electricity, then computer, and AI, IoT, smart manufacturing. Another part is about the stages of the information processing from the day one, around 100 years ago. IBM creates the first punch card machine, then the first computer, then communication networks, then all the way to internet, AI, big data. Seems like we are situated in another singularity time point. For the last mile, it is about time to deploy the investment on the robot in particular for the AI robot development. So we are looking for the talents who can be technology R&D promoters, interdisciplinary collaboration facilitators, and also industry application enabler. Thank you. Here ends my presentation.